Good morning, sir.
Uh, Very good morning. So, good morning to all. Am I audible?
Yes, sir.
Okay. So, I welcome you all for this today's skill development program on Internet of Things and its applications in project. For this program, we have with us Mr. Praful Bendarkar. Mr. Praful is working as a system engineer, Internet of Things in Tata Consultancy Services, TCS, Nagpur. His wide experience of projects in Internet of Things. So we are very fortunate to get the guidance from Mr. Praful on the Internet of Things and its applications in projects. So without taking much of your time, I will hand over the session to Mr. Praful. Mr. Praful,
Yeah, thank you, sir. Thank you. It's my pleasure to give this introduction and see.
Praful, you are not properly audible.
Okay, so is it fine now?
Yes, yes.
Okay, so yeah, hello everyone. I am Praful and I am from TCS. I'm working in TCS currently as a system engineer. I work in many years domain like banking and finance, then the insurance domain, and then also the IoT. So basically, like I have major experience in IoT things. So whatever I am having experience, that things I will share with you today. And what is the industry's application? Like everyone might of you have worked on IoT applications. They have might created the basic application, basic applications for their the many projects, or many of you might be have a knowledge of it because it's a trending topics. So today I will discuss about that thing only, like industry 4.0 and IoT applications in industries and how the IoT is solving our real world problems. So without wasting our time, I will quickly start with a presentation. And before that, just I'm sharing my screen. Okay. So yeah, is it visible, right?
Uh, Not it. Yes, yes. Now it's visible.
Okay. So we are today we are going to see the Internet of Things, that is IoT, trending industry 4.0. What is 4.0? 4.0 might you have understood, like there is industrial revolution happen in the computer science. Like there is semiconductors things that was previously they have been. Then there will be internet connections, banking applications they have developed. Then they have modified some of the applications that is connected to the servers and that things. Previously there were mainframe systems, that is industry 1.0. Then the revolution has been made up in the industries day by day. So today in the industry 4.0 there is huge automation, huge internet of things applications, machine learning things has been happened, so that it makes our life easier, so that we can create applications and we can solve our problem easily. So this is all about industry 4.0. Like it's the fourth revolutions of industry and IoT is come under that. So today we will see about that only. So agenda for today's meeting is we will see what is Internet of Things, that what actually Internet of Things is you might have know, but we will discuss about it. Then how does IoT works, like what is process and how it's connecting with the devices, and why it's IoT is important and why we need that IoT things. Then what are the benefits of that IoT to the organizations, pros and cons of it, any applications that we develop, right? So we create any applications, there should be there is some drawbacks, there is some benefits. IoT is the ones like revolutionizing things, like it started from last some of the years. It's not a technology from past, so there is some loopholes in it, like security one of the concerns that we need to manage when, because there is no standard that has been made for IoT like till yet, because of many industries Suppose one industry is there is working on some standards and other industry is working on some other standards. So when they combine these applications together, there should be some what we can say a miserables, and there should be a comparison faults also. So this standard is not there. So that's maybe the cons in the IoT that we will see. Then IoT standards and frameworks, like what are the standards that we were using, like what is protocols and all that we were using to connect IoT applications. Frameworks basically means you cannot simply create applications like web-based applications using of the technologies like Angular, and that should be get connected to server. That is a simple applications, like it is connected to database and it's showing us the data. So in terms of IoT, there is a different scenario. We need data to be automatically generated. So there will be frameworks that will help us to do our job easily. That is AWS, Amazon Web Services, Azure IoT, that is from Microsoft, and there is many more in the industries, and we can say it. Should be a low-code platform available like ThingWorks. ThingWorks is industrial IoT platform. I will go through it, like what is IoT, what is industrial IoT, and their differences. Don't be confused with IIoT and IoT for now. Just focus on Internet of Things for now. Then we will see consumer and enterprise IoT applications, like what are the applications of IoTs. Then, as discussed, IoT, there is a security and privacy issues that we will discuss. And later we will discuss about industrial IoT and industrial IoT versus IoT. Then the mini projects you can do. I have prepared one use cases that you may try on your own. That is not require much setup for that will helpful for you to understand the things how IoT is working. That is everything. I will give API. I will give to you, and I will give you references and use case so you can try on on your own. So mini projects that will be not take much, 1 day it will take, or 2 day. And when you do in group, it will just take a 1 day. So best practices IoT, when we create IoT applications, what best practices we have to follow. And there is career in IoT, like what is what is what is opportunities for IoT developer, who like it is not like a normal development we do in Java development or application development. There should be a huge scope for these things, so that we will discuss. So firstly we will see like what is Internet of Things. Internet of Things, or IoT, is a system of interrelated computing devices, mechanical devices, and digital machines, objects, animal, people, that are provided with unique identifiers. What these all are devices is capable of generating a data on itself. We will program in such a way that these devices will generated automatically. Suppose I have mentioned here the computing devices that will be generate mechanical devices. Suppose there is an industry which is containing a 10 machines, which is suppose there should be a temperature, pressure, humidity for that machines. Okay, so if we want to see the temperature of that machine, what is exactly the temperature? Operator is the person who is responsible for managing the operations and the machine plants. So he can check, he can create IoT. How IoT will help here? He can connect, he can create applications which is helpful for connecting that temperature data with our application. So the operator who is responsible, who don't need to go there for manually to check that what is the temperature and what is the fault. So there we can create one applications, and easily it can show us the if temperatures go beyond threshold value. Suppose temperature threshold value is 60 for that machine. If it's go beyond 60, so it will be generate some warning message to that operator. Hey, your temperature is goes beyond this threshold value. You just need to take precautions, or there should be some solutions already provided that will be, and then that applications also suggest the solutions to. This is just example I'm saying. So every applications, every things we can connect it to the internet, and that is capable of generating the data. So that, and how we can segregating these devices by unique identifiers, that is the UIDs. And it should be ability to transfer data over network without requiring human to human interventions or human to computer interactions. So as I discussed that there is no need of go there manually to fetch some data. There should be a button and we just click on it. See, give me some data. Manual intervention is not required. So thing in Internet of Things can be referred as persons with heart monitor implant. Okay, so this I will tell you one of the example of best example of this. One scenario happened in US. I don't remember the country exactly, but I think there. So Apple Watch, that wearables you use, so it is capable of showing data to us like heart rate and blood pressures. So the persons who is not aware, like he is feeling fine and all, but blood pressures is goes beyond the threshold value, like 120 and 80 is the normal value, but it is goes beyond that. So he wears that smartwatch and he got notifications like yeah, like the that watch is given him accurate informations like your there should be some functionality, and there is one functionality to if our blood pressures or our heart rate is go beyond the threshold, it will give notifications. So that time he got to know that there should be some problem in his there should be a blood pressure problems or in his heart. So this saves his life. So this is one of the example we can say. Farm animal with biochip transponder. Suppose there should be a goat farm, or maybe you can say is a dairy farms. So there are a lot of animals is there. Okay, suppose 100 animals is there in big dairy farms. So if we connected like the owner of that farm is not able to see it is not that much of free to see her where that hundreds all 100 animals is there. So he just put at some cheap kind of thing in his wherever applicable, he just add that chip into his belt or like that one. So he that is capable of tracking that where is that cow or anything. So it's like the applications. So this is the thing, and that is connected to internet. That's called, we call it as Internet of Things. Automobile that has built sensors to alert a driver when the tire pressure is low. Suppose this is one of the applications you can see. Suppose driver is going and we don't need to check it manually like tire, what is our tire pressures. If we just fitted our some devices over there, and it will alert driver like, hey, your tire pressures is 40 and it is less now. So you just to feel it the tire pressure to make it a normal value. Okay, or any other natural or man-made object that can be assigned an internet protocol address. So how to identify, like how to connect all these devices? We use internet protocols, that is IP address. You might have know about this, like how this we are identifying devices in the internet. So that is IP address that is help us, and it is able to transfer data over the networks. So this is all about basics of Internet of Things. So I will just show you some quick video so that you can get a better understanding. If anyone having questions, you can ask. I want to make the session interactive. Like it's not like one way I'm telling and you are just. So if anyone is having doubt or anyone want to clarify something, so they can ask. No one. At least acknowledge. Like okay, no problem.
The Internet of Things, or IoT, is a system of connected devices, computers, and digital machines with unique identifiers that transfer data over a network. Smartphones, laptops, wearables, sensors, they're all part of the Internet of Things as long as they're connected and sharing data. Beyond that, IoT also includes a person with a heart monitor implant, a farm animal with a chip transponder, or a car alerting a driver to low tire pressure. In a business sense, IoT supports smarter working with more control. Across industries, IoT enables process automation, analysis and insight, labor reduction, and performance monitoring. For example, airlines use IoT sensors for real-time data reporting on airplane engine status and equipment conditions. Theme parks even use IoT to track visitor movement for insight into popular attractions and traffic flow. This can help the park better address bottlenecks, long lines, and even waste management. Businesses are increasingly adopting IoT to improve efficiency, customer service, and decision-making. But all these connected devices are not without potential issues. As the number of connected devices and shared information increases, so do security and privacy concerns. Also, any bugs in a single device can potentially affect an entire IoT system. In addition, and this is true especially for an enterprise, these connected devices produce a ton of data, which can be difficult to collect and manage, let alone glean business insight from. Finally, competing IoT standards can create headaches in terms of getting different devices from different manufacturers to communicate with one another. Still, companies will have to address these challenges because the IoT market is booming and experts predict IoT adoption and spending will grow.
So, as you can see that one of the system is failed.
In this video, we're going to gaze a little bit and talk about the Internet of Things. Second topic for today is on big data, which I'll talk about with video. So let's look at a couple.
Sorry, was mistakenly open. Yeah, so we see that she mentioned about one of the systems is get failed. So everything that is connected in the internet will get failed. So that is one of the maybe a drawback we can say. So we need to manage when creating IoT applications. Okay, so how does IoT works? An IoT ecosystems consist of web-enabled smart devices that use embedded systems such as processors, sensors, communication hardware to collect, send and act on data that are acquired from their environments. IoT devices shares sensor data they collect by connecting IoT gateways or either edge devices, whether data is either sent to cloud or to be analyzed by locally. Okay, so whenever there is a one device, okay, so this is not get is suppose some one device is their machine, we can say it that is from plants that is not able that machine is not responsible to show data the format that we want. Format we want is like JSON format or any other like the processable data to us, but that will not give us data in terms of the processing whatever data we need. So it will give us a raw data. Okay, so how to process this data? So a sensor is responsible for generating a raw data. Sensor data we cannot understand, we cannot directly take into our database and show it to the user visualization UI. Okay, so what here we can do is we should analyze, we can apply the analytics over there so that it can for before that analytics there should be some PLC systems. You might understand that programming logic controls, SCADA systems. So this SCADA systems, we can say it, an OSI pi layer is one of the OS that is useful for responsible for taking this raw data. Okay, so this data is come to this PLC systems, and from the PLC systems we will analyze our data through analytics tools. Okay, so we get data into that devices now. Okay, so how to transport that data to our applications? So there is comes IoT gateways and any other edge devices who is responsible to send data to cloud so that we can analyze it on cloud, or it might be we can analyze in our local system. So this way IoT is working. Sometimes these devices communicate with other related devices and act as informations they get from one another. Devices do most of the work with human interventions, although people can interact with devices, for instance, to set them up, give them instructions to access data. Human can interact like they can set up the what we can say work order in the plant apps. You might not understand. So work order is basically like there should be some plant, so there should be some order processing over there. So we suppose one of the plant types which is responsible for generating a tissue papers. Okay, so tissue papers that plant is not generating in terms of 100, it will be generated in terms of lakhs, and so that work order there should be some shift. So how to start shift timing decisions, like when to start that shift. This for this intervention we might need human interactions. That is only things they were saying in this. So next is, yeah, this is the picture you might understand from this, like you will get better clear clarifications from these pictures. Data investigations, injections, sorry, data that needs to be sent to cloud analysis first to be collected. IoT devices sensor collect this data. As I mentioned in the previous slide, IoT data injections is basically able responsible to collect data from the sensors. Then this data, when we collected this data, we need to transmit this data. Here comes the data transmissions. Data from these devices is sent to cloud via gateways using cellular satellite communications protocols used to ensure data security. Okay, then data processing. Once data is come, so we need to process this data. Processing data can be range from simple, complex, involve verifications and identifications. We need to identify data related to dash systems only. So here comes the identifications. We cannot take directly data from 100 machines. So we need to segregate it basis on the machines, like machine one temperature should be different from machine two. That is only things they were mentioning. Then data is comes to us. We have REST APIs to connect to our applications. Suppose data is come into analytics, and through a DB we are connecting into our applications. So might be use store procedures or anything. So it just data is there now for us. So it's now it started just application work, whatever the simple banking applications or anything. So when now the IoT has been, we can say, like most of the IoT part has been completed here. So now it's part of data visualizations. You can use line charts to show the temperature data. You can use bubble charts. You can use grant charts. You can use got charts. You can use the LED things. So these all widgets are available in the latest tools, so we can visualize your data. Once data is comes, you can make data analysis on it. Data collected over time is analyzed to provide useful insight that can be useful utilized for producing accurate predictions. Yeah, so this is helpful for business decisions to make, like uh, how much productions they have made, this data analysis, how much the tissue papers they have generated for analyzing the data in a year, how much productions they were doing. So this data analysis, these things will helpful in data analysis. So it's example of IoT systems as collects data from IoT devices, example sensors, antenna, microcontrollers. Then collect and transfer data. How it will be transfer data through IoT hub or IoT gateway. Once data has been transferred, it will be comes to user interface, whatever I mentioned in the previous slide. Analyze data, take actions. User interface might be a smartphone, a desktop machines, or human machines, or touchable machines in the plant apps. So whatever might be, just a user interface. It will be here is also a one scope for you, so that you can become a user experience manager, like user experience developer. You can create a you can create a better screens that will be helpful to understand the users. Basically, this is one of the major scopes in the industry. Also, you can make career in it also. So analytics of business applications, then backend systems. We can connect it to backend systems wherever, like SAP we can connect. There will be a MuleSoft. So this is all things we can connect. Why IoT is so important? Like Internet of Things help people live and work smarter, as well as gain complete control over their lives. In addition to offering smart devices to automate homes, IoT is essential to businesses. IoT provides businesses with real-time look into how their systems really work, delivering insights into everything. Like suppose how IoT is helping industries. So they have make their plants automated. So they have saved the cost of labor, and they don't need to put a lot of labors into it. So it might be it is a problem of employment might be, but it is solves their problems. They saves this cost through this IoT. So IoT enables company to automate the processes, reduce labor cost, as I mentioned. It also cut down the waste and improves service deliveries. There is one module itself to managing waste in the plant apps. Like there is should be a machine diagnostic applications and plant is connected. So there is a lot of waste when we do it manually through the labor work. Or I'm not saying labor work is not needed, but some of the things that is can manage it through the IoT with accurately, so that waste can be managed. Some of the waste in the industries that can be managed where that IoT is helpful, making it less expensive to manufacture and deliver good, as offering transparency into customer transactions. So yeah, we will see one video more. Anyone is having any doubts, you can clear. Yeah, I will give you IoT security video, futures of IoT security.
IoT devices, once a sci-fi phenomenon, are in the hands, pockets, and homes of millions of people worldwide. As with any technology, there's the question of its future and its implications on society. IoT security, especially. Gartner research suggested enterprise and automotive IoT market will reach 5.8 billion endpoints in 2020, a 21% increase from 2019. This increase of IoT device implementation will be met with an increase in regulatory efforts too. For this reason, we can expect companies to get more proactive about IoT security by design, said Jessica Grootman.
We're already seeing that. I mean, GDPR is a good example of requiring certain privacy and security by design features or principles into product development. Now, how much of that will be enforced, that remains to be seen.
Amazon, for example, requires companies that wish to integrate with Alexa to have certain security features enabled.
This kind of influence on the market is just one example of companies trying to be more proactive, or if they're an ecosystem players, such as the giant like Amazon, trying to influence the broader ecosystem to be more proactive and more secure.
Look out for advancements in edge computing as well. This local processing of data has big security implications, especially since data is not necessarily sent back to the cloud. Expect growth in the smartphone and healthcare technology IoT sectors, both of which handle extensive amounts of personal data and use biometrics. How to safeguard that information will be a big security focus going forward. Is there a reason to be optimistic about the future of IoT security? Grootman hesitated to say yes.
Where I am pessimistic today is in how organizations have sort of come to deploy IoT with security and privacy as an afterthought. Things that I am most optimistic in are the next generation, digital natives, awareness, comfort, understanding, lower tolerance for irresponsible use of technology. So when I look at the next generation, that is a source of optimism for me.
Only time will tell whether IoT security will drastically improve. But one thing is for sure, IoT innovation is not going anywhere. Ensuring we have security-aware companies and consumers will be critical to getting the most out of this technology.
Okay, so they mention about why IoT helping and why IoT is important in industries. Their security insights they have discussed. So, what are the benefits of IoT to the organizations? Monitor their overall business processes. It's helpful to generate the revenues for them, to monitor their overall business processes. Like we can say, suppose industry, there is a lot of processes they didn't need to follow. Like they need to make the fire drills in the company. They need to follow some standards that should be. So for that business processes, IoT help them improves customers experiences. They solve their problems easily. The customers' problems they solve through the solutions that they are given, so that they improve their experience, save times and money, enhance employee productivity. They have smart tools, smart applications are already available. For example, we can say we don't need to code a lot. We were doing now. So there is many more applications available to create IoT applications itself, like ThingWorks. Low code platforms are available. Mendix. So you can just drag it up. There is also a widget available already. You don't need to what we can say. You don't need to write down the code for that, creating a simple widget. We can say that is a tab widget or a line widget, a line chart. So you just need to drag it, drop it, provide the properties to it, and there is options also to provide APIs so you can connect. So it will be indirectly increases employees' productivity in smarter way. Integrate and adapt business models, make better business decisions, and generate more revenue. Yeah, pros and cons. We can say some of the advantages of IoT that we discuss a lot. Ability to access information from anywhere. We can access it from anywhere, from our device, from mobile or from desktop, anywhere. Improved communications between connected electronic devices, transferring data packets over the internet connected, saving times and money, and automating tasks help improve quality of business services, reducing the need of human interventions. So we have discussed a lot of benefits of it. So we'll see some of the disadvantages. As number of connected devices are increasing, more information is shared between devices. So IoT device is responsible for generating a huge data, because data is generating in milliseconds. It will not generate hourly data or a day data. It will generate a data in milliseconds. One, because sensors is responsible for that. So there is a huge data. So potentials that hacker could be steal the confidential informations. These things is also increasing day by day. So we need to provide a proper security. Enterprises maybe eventually have to deal with massive numbers, maybe even millions of IoT devices. Collecting and managing data from all these devices will be challenging. Here's one challenge, like they have a lot of devices. For example, 100 devices is fine, or 1000 is also fine, 10,000 is also fine. But if they are having a lot of devices, we can say they are having in lakhs. So that times there will be a challenge. So this people's research and researchers are working in that in the IoT. If there is bug in systems, it's likely that every connected device will become corrupted. As that I have shown that video, she mentioned about that one of the systems get corrupted because IoT is interconnected devices. So it will be make other systems to effect on the other systems too. That will be indirectly down our applications, make a downtime in our applications. So that is maybe cause of problems to the businesses. Since there is no international standards of compatibility for IoT, it is difficult for devices from different manufacturers to communicate with each other. This is points also I have mentioned that suppose there is no international standards now they have created for compatibility of IoT devices. Suppose one of the companies creating a gateway devices, uh, which managing their standards, and other also companies also creating gateway devices, they are managing their different standards. So there should be the standard should be same, so there should be not a comparability. So this is might be the issue while we creating the IoT application. So this is not my, but they are working, the researchers are working to solving these problems and make the IoT a better day by day. Okay, so we will see IoT standards and frameworks. IoT standards is basically a protocol we can say, which is helpful. That is IPv6, Zigbee, Light OS, COAP, AMQP, and one more, that's the MQTT. I have not mentioned it, forgot to mention. But you don't need to worry about these protocols, and it's just a informative thing. So you can take one of the protocol. MQTT is a messaging queue transport protocols. Then there will be IPv6 advanced messaging queuing protocol, AMQP. Here comes the important things: IoT frameworks. AWS, Amazon Web Services. They have provided a separate modules dedicated for IoT itself. You can manage your API, you can manage your devices in it. There is also one competitors, Microsoft Azure, Mindsphere. Mindsphere is also from Siemens. It's applications from Siemens, which is responsible for managing IoT devices, for managing a plant's ThingWorks, as I mentioned. It's a platform as well as it's a we can say low code platforms for developing applications also. We will discuss more on that. So IPv6, IPv6 overload. I don't know about these protocols much, but I have just mentioned information. I will tell you. IPv6 over the lower power wireless personal area networks is open standards defined by Internet Engineering Task Force. The standards enables any low power radio to communicate to the internet. Then Zigbee. Zigbee is a low power, low data rate wireless networks used mainly in the industrial setting. Zigbee is based on Indian Institute of, it is designed by IEEE itself. So it's 802.15, some standard is there. Zigbee Alliance created .NET, uh, dot, dot, universal language for IoT that enables smart objects. There is some, that is one of the language. Light OS, it's based on Unix systems. This is basic. This Light OS is used in smart homes. Smart homes applications, which is like it will be saves energy. Suppose you are having a fan in your home, you make it smart to the IoT. When you are not in the home, the sensor will be will check that the presence of somewhere presence is not there, so it will be automatically turn off that fan or turn off that lights. So this is one of the best applications helpful in saving our energy. So it is also using smart devices, one M2M, a machine-to-machine service layer, then DDS developed by Object Management Group, then advanced messaging queue protocols, open source public standards for asynchronous messaging by wires. Okay. Then COAP, then long range wide area networks. Okay. So frameworks is AWS. AWS IoT is a cloud computing platforms for IoT released by Amazon. The FIS frameworks is designed to enable smart devices to easily connect, as I mentioned, and securely interact with AWS cloud or other connected devices. ARM Embed IoT is a platform to develop apps for IoT based ARM microcontrollers. The goal of the ARM Embed IoT platform is to provide a scalable, connected, and secure environment for IoT devices by integrating embed tools and services. Okay, Microsoft Azure IoT Suite is a platform that consists of set of services that enables users to interact and receive data from their IoT devices, as well as perform various operations over data, such as multi-dimensional analysis, transformation, and aggregations. Visualize those operations in a way that's suitable for businesses. So here comes the machine learning parts. It will be transform that data, aggregate the data based on business logic, and visualize the data in a format like line charts, the previous predictions, last predictions of the productions. So that is helpful, suitable for business. Business will not understand data from the sensors and all. So they need a better UI for that. Google Brillo View is platform for rapid implementation of IoT applications. These are huge platforms in market. The platform consists of two main backbones, Brillo and Android-based OS for development of embedded low power devices, and View, an IoT-oriented communication protocols that serves as communications language between the device and cloud. Calvin's open source IoT platforms released by Ericsson's designed for building and managing distributed applications that enables devices to talk each other. So yeah, so here comes the important part: consumer and enterprise IoT applications. What are the applications of IoT? Smart farming. Smart farming is helpful for farmers to generate the data, the crop information such as um, moisture in this moisture and all data like related to that, so he can make better decisions, what pesticides he need to do and all these things. There is fleet tracking is basically application is one of the famous IoT applications that is used by all our industries. Fleet tracking we can say it, there is some courier industry we can say for example. So uh, they are having 10 to 15 trucks, the owner of that. So he's able to manage, we can one truck we can call it as a fleet. So he can able to track that where that truck is, where the driver's behavior, whether he is driving in speed or whether he is how for tracking purpose this application is helpful. Then healthcare, we can say smart buildings, wearables, one of the examples I have discussed, plant manufacturing, machine diagnostics apps. Plant manufacturing's machine diagnostic app I will discuss in the next slide. So industrial automations, as I discussed, industrial automations is basically like the manual interventions. They have solved this problems of manual interventions like factory digitalizations. They have made a factory in a digital way that so that they have made applications. They have connected to all the plants. Suppose one of the factory, we can say for example ABC is the factory and having 9 plants. So 9 sites is there. So and there is and they have created one applications to manage all these factories operations digitally, so they don't need to go there, so that factory is automatically responsible for generating data, product flow monitoring, inventory management, safety and security, quality control, packaging optimization, logic and supply chain optimizations. Okay, so industrial automations, we can say smart tracking for product in transit, notifies users divisions in delivery plans. This is high level language, might you not understand. I will not talk much about it. I will just give overview to it. Create digital factories, improves line of command in the work units. Okay, then monitors real time throughout supply chain. Supply chain industry, is like they have they generate products and there should be production lines over there, so that lines managing operation there is one operator. So for operator, um, as you can see might be in this later picture, so they have 10 machines, so operator will not go manually over there to check machine every machine one by one. So just uh, he is having on applications, he can track where that what machines behave, then product quality testings in various stages of manufacturing cycles, packaging optimizations. Yeah, fleet tracking as mentioned previously, fleet tracking might be anything anywhere. It's one of the applications from IoT. Fleet tracking, fleet might be anything like be truck, it might be ambulance van, might be a safety security medical fleet, and might be a bike, might be a taxi assignments, cargo logistic assignments. So how it's helping to monitor public convenience. So one of the countries they have designed one applications, IoT applications to track their buses, local buses where the user can install that applications and see the status of the bus where that bus is. So that is one of the applications. Ambulance assignments, like one applications we can create to check the status of ambulance where ambulance is. Then we can taxi assignments. Ola Uber, might you have seen that Ola Uber's applications, they have GPS systems stack. When we book Ola Uber taxi, so we just see that where how much time that will be take driver to come to us, and how much time taxi will come. So you can also see that where the taxi is now. So that is one of the applications of IoT, we can say. cargo logistic assignments. Yeah, as I have discussed, like there is one many delivery courier partners, so they are using IoT. They are having their trucks to like 100 trucks is having one of the one owner is having 100 trucks, so he can use fleet management applications. Every truck, that 100 truck is having one sensors when GPS systems into it that is capable of generating data, and that sensors are connected through the satellite, and to that satellite it is connected to that operator, that owner's what we can say mobile device, or might be a laptop or anything, any devices. So he can check that, oh, driver is uh, he's driving in the speed, normal speed level or not, or where that actually the truck is how much, why is like the delivery time he can track and all. So yeah, so this is all applications. This is one of the diagram, so that you can understand the fleet telematics setups. So there is satellite GPS systems which is capable of generating data, and in vehicle tracking devices there that is enabled with the GPS. So through that cellular or satellite networks, it is connected to secure server, and that from secure server it is connected to that fleet management software where he can visualize data like tracking of the things and all. Yeah, smart farming. So as we can see that the this is not this is just a revaluations is going on. In other countries, they have implemented these things. Smart farmings is like they are having farmers is having a lot of asset. One of the maybe say that tractors, might be say that drones they have used, might be they are having a farms, the cow farms. Then they will having 2 to 3, like in pictures you can see that cows there. Okay, so futures of the farms, they can create one applications of IoT where the tractor, for example, it's connected is having one of the sensors is responsible to generate data like fleet of agribots. A herd of specialty agribots tend to crop, weeding, fertilizing, harvesting robots capable of microdot applications to the fertilizer, reduce fertilizers cost by 99.9%. So okay, so smart tractors, GPS controls steerings, optimize. This is advanced level. I will not go into deep that much, but we can say that this applications for this dairy farming that has been implemented already. So we can we can track the our animals, that the dairy farms animals. We can track where is that if they go beyond the that farmhouse, or we can say, so it is responsible for that. Yeah, greenhouse is also connected, we can say, through the IoT. As you can see here, inside greenhouse there should be light, might be a fans, might be a ventilator fans, then all these things. So on off we can we can do through control and switch gear. Yeah, one of the most important properties of IoT is capable of sensing the data and sending the data. That is only one of the properties of sensors, we can say. So sensors and actuators you can see here, and this once this data is getting generated from these devices to that sensors, there here comes the connection gateway. Connection gateway is one of the devices, hardware devices, is capable of connecting data to the cloud, and cloud is having data from these all devices into it, and from smartphone or from desktop machines you can connect to this cloud, or you can connect to this gateway and get your data and visualize your data here. So it's one of the applications you can see. Then IoT security and privacy issues. Internet of Things connects billions of devices to the internet and involves the use of billions of data points, all of which need to be secured. Due to its major expanded attacks surfaces, IoT security and IoT privacy are treated as major concerns. Okay, so because of IoT devices are closely connected, all hacker has to do exploit one vulnerability to manipulate all data rendering it's unusable. Manufacturers that don't update their devices regularly at all leave them vulnerably to the cyber criminals. Okay. So additionally, connected devices often ask user to input their personal informations. Here comes the attacks that is not attack but might be asked to enter the personal informations into like credit card informations or debit card information. Fraud is happening, so that is one of the security concerns to the IoT applications that we develop, including names, ages, addresses, phone number, even social media accounts, information that is vulnerable to hackers. Okay, so till now we discuss about IoT. So, is anyone is having any doubts? You can clear. Like I'm going in one directions. If anyone is having any doubts, you can ask. Or should I go ahead? Okay, no reply from anyone.
So students, if you have any query, you can ask, make the session interactive.
Anything like it's not like one way we can say I'm just going through because I am not telling you industrial point of view because that applications are proprietaries. I will tell you that also. That is that you might understand this might be a higher level for you, but you can just ask anything if you have.
Praful, I hope everything is clear, so you can
Oh,
continue.
no. Yeah. So we'll quickly go to industrial IoT. So don't be confused with IoT and industrial IoT. IoT thing is clear. So IoT is responsible for generating data and connected internet is there, and that is responsible for managing operations by using that data. Now comes industrial IoT things. Industrial IoT, whatever I mentioned in the plant and all. Industrial IoT is Internet of Things, also known as Internet, Industrial Internet, brings together a critical assets. Asset is what? Asset is one of the machine plant tabs in plant tabs. So we can say it as asset. Advanced predictive and prescriptive analytics, modern industrial workers. It is the networks of multiple industrial devices connected by communications technologies that results in systems that can monitor, collect, expand, analyze, and deliver valuable new insights like never before. Okay. IoT has transformed industrial IoT, sorry, not IoT. Industrial IoT has transformed industry, changing the way industrial companies operate from day to day, whether it's enabling industrial AI to detect corrosion insights, a refinery pipe, providing real-time productions data to uncover additional capacity in plant, or accelerating new products development by feeding operations service data pack into product design cycle. By combining machine-to-machine communications with industrial data analytics, IIoT is driving unprecedented levels of efficiency, productivity, and performance. As results, industrial companies in power generations like oil, gas, and utilities, manufacturing, aviation, and many other industries are experiencing transformative operational and financial results. So this is whatever I mentioned. I will just tell you in short, like what industrial IoT is. IoT is basically is responsible for generating a data from a variable devices. We can say, okay, next slide is there. Indus IoT versus I will clear this in this slide. So one of the perspective is to think that industrial IoT, connecting machines and devices in industries such as oil, gas, power generations, healthcare, where there is more are stake and where systems failure and unplanned downtime can be result in life-threatening or high-risk situations. On other hand, Internet of Things tends to include consumer-level devices such as heart rate monitoring, fitness bands, smart home applications. They are functional and can provide convenience, but do not typically create emergency situations. So here is major difference. Okay, if we create industrial IoT applications is basically and industrial applications like machine diagnostics application, we can say there are 100 machines that are connected to internet. Okay, so one of the machines is get failed because of some connection issue in the internet of things, so that might be create a problem. But IoT is basically not, it is not connect, what we can say, it's not like plants or anything, it's just dedicated devices, we can say, like variable devices, that is our smartwatch. Then there should be some other smartphone applications. So there is not we can say that 10 home is connected by uh, IoT platform. There is only one home which can manage, that is called as IoT. But a plant manufacturing company is having their 10 plants to manufacture their tissue paper or anything that they produce, like they have produced some the mechanical parts. So they are having many sites of theirs, like 9 sites they are operating from. So for managing all these sites, this industrial IoT is helpful. For example, digital twin is a great example of how industrial internet enables machines that tells operator of how to optimize productivity or to detect failures. Failure detections is mainly important in industrial IoT. IoT is also important, but that not much. It will not create a business impact on it. So potentially saving companies a billions of dollars in a year. So industrial IoT is saving a lot of cost of industrial operations. As industrial internet connects critical machines, it can deliver powerful financials and operational outcomes. For example, one of our customers from power company, this is one of the data from one of the company, is annually saves a $0.5 mm. That is that's this huge cost is being saved by implementing industrial IoT things over there in their plant apps. So it's indirectly saving the cost. So that's why people are going and people are moving towards IoT and industrial IoT. Manufacturing customers increase capacity by 20%, reduce lead time to customer delivery. Delivery is also getting impacted over here because smart applications, smart tools are available. Then development is also completed within the, what we can say, whatever it will take by using low code platform. Development is also getting completed within less times. As more as data is created from increasingly connected machine systems, devices, the volume of critical and valuable insights to be realized and acted upon limitless. Okay, so this is all about that we discuss about industrial IoT and IoT. So I will just quickly show you one video so that you might get better understanding of IoT versus industrial IoT. There is one video. Yeah.
My job is to make college easier because students have a lot.
Automation and internet cloud computing are evolving and merging into a space allowing for artificial intelligence or AI programming to facilitate improvements in productivity and efficiency with many economic benefits. Along with internet cloud computing and other advancements with the internet, we are now in the middle of the next industrial revolution, mining and turning data into information. This period of evolution is called Industry 4.0, or the Fourth Industrial Revolution, which includes industrial internet.
The same thing I have mentioned before starting this presentations. Industrial Internet of Things is the 4.0 industrial evaluations. So that's the same thing they will.
Internet of Things, IoT, and digital transformation mechanisms that facilitate this evolved fourth generation period of automation. In this lesson, we will learn about what is the Industrial Internet of Things, or IIoT. While the Industrial Internet of Things does follow the Things, or IoT, area of influence, the key difference is IIoT concentrates on the connections of machines and devices in industries like manufacturing, healthcare, and logistics. IoT is commonly used to define consumer-based devices like Fitbits and smart home devices, for example, refrigerators, Ring video doorbells, lighting, thermostats, and alarm systems. IoT is about getting information that every single consumer needs in their hands when they want it. And digital transformation is the digitization of a business and how we must move to a unified, organized data space using the International Society of Automation standard for developing an automated interface between enterprise and control systems, or ISA 95. ISA 95 essentially provides a hierarchical model for the enterprise, site, area, line, and cell. Each level of this architecture uses a specific software system to gather data for that part of the organization needs, in which creates a problem for communication between these disparate applications. With most organizations, the data is not real-time and lacks efficiency, inhibiting key stakeholders to make informed decisions. IoT is about making decisions from information received real-time and not from a report created from yesterday's data. The industrial Internet of Things is all about interconnected instruments, sensors, and many other devices that are networked together and communicating with computer-driven industrial applications for many manufacturing and energy management areas of business. IoT is an evolution of a control system that allows for a significant improvement in automation by using cloud computing to enhance and optimize process controls. Industrial IoT depends on many technologies, but the key technologies primarily consist of artificial intelligence, cybersecurity, cloud computing, edge computing, and data mining. Artificial intelligence, or AI, and machine learning, or ML, are fields that are part of computer science. AI is where intelligent machines are developed and respond like humans. And ML is where machine learning is part of AI predicting and a more accurate outcome delivered without programming. Cybersecurity technology becomes an important basic platform for IoT and IIoT, enabling disconnected machines to physically connect and communicate in a secure method. Cloud computing is basically using IT services and the files to be uploaded and downloaded from internet-based servers, opposed to using local extranet-connected servers. Edge computing is a distributed computing model, bringing data storage closer to the location where it is needed and optimizes sensors, industrial computers, and devices that are part of the IoT system for publishing and consuming data for faster processing. Data mining and analytics are about collating and examining large amounts of data stored from various parts of the enterprise. Okay, so why should we go through this somewhat major transformation, and what are the benefits? Companies want to be more competitive, increase efficiency with just-in-time manufacturing and meeting higher customer demand with better inventory control. We can do all of this with the creation of the organization's overall automation, a digital twin. A digital twin is a virtual representation referring to a digital replication of the actual company's physical assets, processes in place, automation systems, and devices. The twin uses real-time data to enable learning and reasoning for.
So this is actual process, that is the machines, and this is digital twins is the virtualization of same thing we can say in applications. So suppose I want to make this machine start, I will go into applications, and this is the digitally connected. There is only options here available. Don't need to go there to the physical machines to turn it on/off. There is options available, so you can directly turn off on from here. Here is the properties also: torque, temperatures, speed in PRM, speed, a nanometer torque value, the Fahrenheit temperature value. So all these things I will get in this digital twin. That is, digital twin is digital representations of this physical assets. This is one of the asset in Internet of Things. Every machines that is connected, it's called as one asset. So we are having a digital representations of the same thing here. So, and you can see that you can check their properties, temperature values and all directly from here. Don't need to go there and check it manually. If there is fault comes, there is also facility. Suppose a normal temperature, normal torque value. Torque is one of the properties of machines that is generating. So this is one of the mechanical properties that is machine generates. So if go beyond the 500, suppose this is normal value, it's go beyond 520, it will alert the operator who is responsible for managing operations into that plants. It will tell him that if hey, the torque value is goes beyond 500, do the needful solutions to it to make the machines operatable in the normal way. So this is automation. This is what we can say, the automations and the internet of things helping here.
Improve decision making. The digital twin allows experimentation with new information that is generated by cloud-based AI functions without having to shut down production or be concerned with personal safety because testing is performed in a virtual space. Also, the digital twin
Safety is also there. Operator don't need to go to actual machines to check it, because if he goes there and something wrong happened to him, there might be accidents or might be something issue. So that is also one of the benefits that is helping by industrial IoT things. So we can make it, we can manage it virtually.
and could be used as a training ground for new employees without impacting the live system. And when comparing IIoT and IoT failures, IIoT create much higher risks than IoT. Life-threatening situations or major financial losses could happen from an actual system failure or downtime, for example. While we may benefit from a long list of benefits through the IIoT transformation, there are some concerns and risks we should be aware of. Some of the potential risks of adopting IIoT are expense of the cost of data integration, lack of experience, and difficulty of implementation, and the devastating cyber threats. Data integration is one of the biggest obstacles to IIoT implementation. You could be looking at building a system with thousands of existing connected sensors and devices, adding new equipment and software systems, and interfacing legacy equipment to communicate using standard IIoT protocols. There is a high cost of integration preparing for IIoT, requiring new software, hardware, and equipment. You will need to consider the costs of associated training your existing workforce and hiring new staff, and the time needed to get workers productive. And the lack of expertise with integrating IIoT requiring automation companies
So see here, they have made,
to be fully experienced.
they have given automation pyramid. Okay, so this is all what we can say, the systems. This is industry which consists of this pyramid. Okay, this is all the systems which is connected, which is having a sensor, actuators, which is responsible for managing the data. Okay, then there is PLC systems that is connected to the systems. PLC is programming logic control, is dedicated for this. They are having one chip, they have programmed in such a way that is able to fetch this data from here. Okay, then there is HMI SCADA systems that is connected to this PLC. Okay, so MES is also there. Then ERP systems. So this is one of the pyramid which is required in automations thing. So this is, in this way only industries are managing their IoT operations through this structure.
With an organization's layers of systems, starting with the plant floor transmitters, process PLCs, operation HMI, and SCADA, reporting based on database administration, manufacturing execution systems or MES for warehouse control, and enterprise resource planning or ERP or accounting systems. Now, integrators are required to have expertise in machine learning, data science, and real-time analytics. In the long term, IIoT could more than pay for itself, but many organizations are still justifiably concerned about investing so much in IIoT. On the bright side, the benefits of IIoT in manufacturing, pharmaceuticals, agriculture, mining, oil and gas, and retail are gaining ground, and many companies are embracing this new paradigm for solutions in optimizing operations and personnel productivity. Many manufacturers have already achieved process performance and have reductions in downtime. And while manufacturing is certainly leading the way with IIoT adoption, other industries are becoming open to the idea of embracing IIoT, for example. This concludes the video. What is the Industrial Internet of Things, or IIoT?
So hope you get some insights into IIoT from this video. Okay. So this is all about the topics. So we will be discussing about many projects you can do. This is just a high level discussions of IoT. But from your side, what you can do is I have prepared one use cases you can try. That is mini project, weathercast applications. You can make the dashboard. Okay, you can make dashboard, and in that dashboard we can make some HTML page or using any UI set technologies like Angular or anything. So you just create a user interface into it, based on city. You should show the weather forecast details of it. Like when you select a city from drop down, it should show the weather forecast details in the Google Maps. You can integrate Google Maps through the Google Map API and show your data. So and you can also make the line charts and you line charts for the month forecast. I will show you in screen. There is one. You can use this API. Okay, so you can create weather forecast applications, and it is just simple applications. You can just put some drop down, like city list, 5 10 cities you can put, and based on selections you can show that city in Google Maps, like marker is there. Okay. So and when click on that marker, it should show that city data, like what is the temperature for that city, humidity, pressure, wind, all these details. And if user want to show the last month data, that you can show in the line charts. So that is basic applications of IoT you can create, because you don't having that much of resources with you, like sensors and all. But you can try. You can use ready-made APIs from open source. Weather API is there. I will, yeah. So this is one of the open weather map API. You can see that here you can use this APIs to show your data. There is here you need to go to API options. Okay. So current weather data. There is API docs available. You can just give this. You can just copy this API into your when you create your applications. You can put your city name over here, and you just need some API keys from here. So you can put it, and you can use this API to connect it to your applications. So you will get city wise data accordingly. So you don't need to, what we can say, it's we can consider this data is coming from IoT weather data, and you can connect this API in your applications, because it's indirectly weather open weather API is connected to the what we can say, sensing data from the sensors only. So you can use this. Yeah. So there is one. I don't know it is free or, but there is options available. So you can use this API, and there is Google Maps API keys also. You can use to show your data, your city-wise data. Like, wait just a minute. Maps. Mm, no. They have made some changes into this site. They should there should be some API when you log in with your ID. You will get some API key that you can use. I will show you Google Map what you can do in application. Mm, okay. So this map you can integrate in your application through API key. When you put your city name over here, like you can make drop this similar way, or you can add the drop down kind of thing over in the applications also. If you put your city name like Mumbai or anything, so this marker will come here. Suppose this is marker you can see. Okay, so this you can manage in your what we can say, you can manage it by using a Google Map API. I will show that also. So you can create one applications UI specific. You can put some drop down, or you can use these things also. You can put your city and marker will come over here. When user click on it, okay, so now it's showing data for latitude, longitude, and this is the details of it. You can modify these things in Google Map API, and you can show the temperature, pressure, and the humidity and all details here itself. So when user click on this, the current temperature value, current pressure value, it will show to the users. So you can make this a small use case, so that you can get basic insights of application creations. And because in many of the industrial IoT applications using these things, so you can use this. Okay, so API, okay, just need to go there. There is some API key you can use, and as you can see that there should be a features available to similar way. He is a marker, and when you click on this, it's allow you to what you can say, it's allow you to show the data to routes is basically for start. So it's asking for me to log in. Okay, let it be. So you can create this mini application, like you just create some minute. I will give you you can create this dashboard kind of thing like this page. You can add a drop down over here. This is responsible for selecting a city. Okay, then you can add the screens, and here in this screen you can add a Google Map using API. So when users select city here, it will show the marker in the Google Map, and on click of that, it will show the weather, temperature, pressures value. So how to get this? By using API of weather, open weather API. Link over here. So here you will get a API, and you can try it out like to extend. So you just need to go to this site, and you need to integrate this API into your applications, so that you can get a ready data available over there to show here. And in the again, you can just create a next page, or you can just make a tab to show the history data, and you can add the line chart over here, line chart in terms of lines that is available widgets. You can add from any technology, from Angular or anything. You can add line charts. Okay, and in that line charts, you need to give some options to select a city or not a city. Yeah, city also, and what data you want in this line chart, like last 2 days, last 3 days, last week, or last month, anything. That filter you can apply here, and you can show that data in the line chart. And I will create this is page 1. You can say dashboard, and another one is sorry, I'm not formatted well, but just quickly I want to make. So this is the second page. We can call it history or history forecast, anything. We just add it history forecast. This 2 page, when you made it, you just create application tabs. One tab you can add this dashboard, and other tabs you can add this history forecast. So similar way you can create some mini projects also. Okay, so this is thing, you can take a screenshot of it if you want. So this is mini projects, and what we want to discuss again. Yeah, I want to discuss with you some of the tools and technologies that is using in industry with the mini projects. So these mini projects you can try on your own. The API on all you can get it. You can research about it, like how to get it freely with your account. You can try to log in with your Google account for Google Map API, and you can use trial version of it. Like they will provide some trial entries, some subhits they will provide for free. So you can try that API over in your applications on your own. So you can try this project. Then best practices to create IoT app. Choose a platform wisely. There are many platforms that you can use to build your IoT application, but you need to choose platform accordingly to your need. Whether you want to make industrial IoT applications or whether you want to build IoT applications, then choose of hardware, then things of scalability in advance. Scalability is most important thing in IoT. That is need to be taken care when we start your development of your applications. So this is high level discussions that you might not understood, but maybe just I will give quick overview. Make sure your app is fast. It should be it should be not like the speed of that loading of app and all should not less. So it should it should do the operations in a milliseconds, because the device is generating data in milliseconds. Take good care of security. That is one of the major concern. When you create any application, you need to take a good security. Then best practices to write down a better code. That is I'm not going to cover this. Just I wanted to tell you, but let it be. Whenever you just write down the code, you need to write do whatever you code. Just when you start coding, you just need to make coding in such a way that a comment you need to provide it what purpose that code you are writing. That is main important things. Documenting is like suppose you have developed one solutions or you have developed one fix, like how to connect it to the database by using some of the steps that you have followed. You can prepare that document and you can share with the other colleagues of yours, so that that will be helpful for them also, so that they can understand the processes. So this is one of the things. Then you can don't reinvent the wheel. Like you can reuse the solutions that's already developed. So if solutions is already developed, you don't need to develop that same solutions again. So for that, documentation will be helpful. Make sure his code is readable. Readable code is like you can make a naming convention in such a way. You should not make like, yeah, dashboard new dashboard latest, like that way you cannot put a name of page or anything. You just make it a dashboard or anything like dashboard version v.10, like that way, so that it will be understood properly. Limit your line length, try to minimize the coding length, like make it code optimized in such way that the 10 lines of code you just try to make it sometimes you do repeated operations that will be not cause of problems when you start developing a code, when the small application is small, but when applications is having a lot of services, lot of data is there, that time it creates problems. So that is one of the concerns, naming conventions. So this is on one of the things I wanted to discuss. So main things is tools and terminologies industries are using. So you might have experience, quite practical experience of yours, like experimenting things. You have a practicals of Java, C, C++, operating systems, database. So these are the basic knowledge you should need to build, like one of the object oriented you want to go. So you need to basic understanding of sorry, not a C++, or Java, anything. So basic understanding you want, like what is abstraction, that should be clear to you when you start your coding journey, or when you start your industrial journey. So that you need to taken care, your basic should be clear. Everything that is helpful in industries also, it's not like when your basic is not clear, then that is not helpful. These all are the advanced tools. This don't need to write down the code. There's already available scripts, snippets is also there. So but your basic should be clear, so that you can understand, you can build a logic easily. So, for example, you're working in Java, so everything for Java, basic knowledge. What is inheritance? What we can say? What a polymorphism do? An actual real world scenario you can understood, and you can try that code, like how actually it's working, how inheritance is working, how I cannot inherit multiple classes in Java, why multiple inheritance is not allowed in Java. So how, where that come, the interface things is come, what is interface to make the standards. So that basics you should be clear. So STS is one of the Spring tool suite. The Spring frameworks is when we start development in industry, you it's already 11:30, but just I will quickly I will quickly finish it. So yeah, STS. Suppose coding you are doing in Java, so industry is not following the same standard. Is they are not line by line. They will not. So they are using tools or frameworks. So Spring is one of the Java frameworks which is responsible for creating Java applications, microservices, or RESTful web services. So Spring tool suite is one advanced part of Spring. So it is helpful for creating Java services, so that we can return our Java services easily. There is, it's like Eclipse, you can might be have seen. Agile is the one of the methodology that industry is following. Agile is like there should be a daily issues discussion. What is it's not like waterfall things. Once you when you start development, and after that development finish of 3 years, and then you discuss with the issue, it's not like agile. It's agile is like you do development for a day, and if issue is faced in that same day, you will discuss with your team members to resolve it, or what is backlogs in it. Postman, REST APIs like get API to get the data, post API to post this, all the REST APIs also. Testing this, Postman is the service, Postman is the applications available, so that it will, Postman is the applications to test your RESTful API. Visual Studio Code might you have used to create your applications for Angular applications or anything. So Mendix is a low code platform. Mendix is low code platform. Here you don't need to write down a lot of code. It's a proprietary application, even though you can directly drag it off. You can directly drag the line widget also, and you can start your development easily. ThingWorks is also similar way. As we discuss industrial IoT, this is one of the marketing booming platform in industrial things that we are currently working. ThingWorks is responsible for managing. I will show you video quickly after this presentation finish to the ThingWorks specifically. So MindSphere is similar to ThingWorks from Siemens. Then Apache Tomcat, this is server that might used. Then Microsoft SQL Studio for managing SQL operations like store procedures, AWS that we discuss, Azure DevOps. DevOps is CIDC, continuous integration, continuous. Whatever you have done development, okay, whatever you have created, you finish your development, you need to upload to DevOps daily. Like this is a process that is connected, so that it's not like dependency on any developer. If he was one of the developer is not present on that day, so whatever the code that is on DevOps, it's like cloud we can say. So whatever code we develop, that is already uploaded in DevOps and you can take it from it. Dev QA prod environment, what are all these things? So normally you create any applications, okay, when you create any application in industry, there are environment one by one. So what we can say, there is servers, dev server, QA server, environment server. So you finish your development of your applications in development. So you are tested on your unit testing you have done, and you have done unit testing. Like unit testing means you have tested your code on your own. So this is the development environment where developer work. qa is the quality assurance environment. When you finish your development, you just move that code to the quality assurance environment. Quality assurance environment means when it is testing by you, a developer, and development, then it is getting tested by tester in qa. So once tested properly, like everything is working fine, there is no issue in quality assurance. The same code we will move in the production environment. Production environment is whatever that is go live, that is whatever there in a real world, real application deployed, that is the production environment. So careers in IoT, yeah, as there is huge scope for it. You can try, you can make a mini project started, and you can learn more about. You can do any courses. You might have Udemy access or anything. You can try on YouTube. You can just search like step by step. You can go like what is IoT, and you can see because YouTube is having huge data for that, so you can easily get that. I will not going to deep into it. So conclusion is IoT is solving our real world problems through the technology, making our life easier, but we need to take care of security. So that is one of the major concerns. So this is the references that I have referred and I have presented you. So I will quickly show you just a last video that is based on ThingWorks specifically. So ThingWorks is industrial IoT platforms. So that is ready applications, and that is helpful for you to create application easily. Even though that is proprietary platform, but you can try to download on your own if you wanted to trial. You can give 1 month trial. This is from PTC company. Just I will show you. Yeah, industrial IoT platform. That is, they will show link. What is ThingWorks is used for? ThingWorks platform is a complete end-to-end technology platform designed to industrial IoT things. ThingWorks platform. ThingWorks download link. I will go. Yeah, free trials. This is proprietary application, but you can try freely. You just make it, note down, and make the research about it. ThingWorks. So this is available in cloud, and locally you can also install. So there is installer file. It is 90 days free trials is available to you, and you can, because their materials courses material is not available freely on YouTube, but basic understanding you can just go through it. What is that? What is useful for it? What is the use of this thing works? And there is sites available internet. You can try that. So I will show you a quick video on ThingWorks.
The ThingWorks platform makes it easier and faster to realize efficiencies and to reduce risk in your operations in all kinds of settings: utilities, smart cities, oil and gas, and of course in factories, all of which are constantly generating critical operational data. For many of you, acquiring and making sense of the data is a major challenge. As you can see in this example of a role-based app, which is connected and built for a factory, ThingWorx makes it easy to source data. That is, incorporate and aggregate data from anywhere, wherever it is, and understand it across various production lines. Only ThingWorx allows you to structure and enrich this data in a way that makes sense in the industrial IoT. To organize data from these physical assets, from your digital systems, which might include PLM, might include 3D CAD, and then enrich it with ThingWorx's IoT context. Now we can take advantage of this information, right? We can gain insight into these assets, into these operations, and drive behavior and outcomes. At the heart of every IoT solution is synthesized intelligence. Intelligence that helps us answer the hard questions about an organization, a product line, a process, or an operational unit. ThingWorx also provides easy-to-use tools to apply supervised machine learning to your data. And these capabilities is happening. Why it happened? By automatically identifying statistical patterns, relationships that affect performance. What will happen? By automatically creating and operationalizing predictive models that are based on historical data. And should happen with recommendations that optimize the likelihood of desired outcomes based on perceptions. But what about us? Now that we have this data-driven intelligence, the next question is, how do we automate the processes that connect our business system data, our physical products, and our operations? In other words, how do we orchestrate? So if you're a system admin, I'm sure you'll agree that orchestrating processes across just one enterprise level system, think about CRM, ERP, can be challenging. And when we think about the industrial Internet of Things, with many disparate systems, lots of different sources of data, connected assets in the factory, connected products in the field, that challenge grows exponentially. Solving these challenges is what ThingWorx is built for. It has utilities that are designed specifically for managing and orchestrating across devices, across processes, and across your business systems. How can we easily make data and insights accessible and enable people to make smarter decisions and execute informed actions, to engage with the connected systems, and to use all of this rich, insightful information so that they can do their jobs faster, they can do their jobs better, and they can make better decisions in their day-to-day work. These capabilities enable connected solution builders to clearly present relevant, compelling information through the web on the desktop, on a mobile app on your phone, as well as with augmented reality experiences. Speaking of augmented reality, how hot is this technology? This is fantastic stuff, and it's already changing the way that many of you are creating and selling and servicing and operating the products that you build. Last year here at LiveWorks, I introduced you to ThingWorx Studio. This is a purpose-built authoring environment that makes creating AR experiences unbelievably fast and easy. And also, you can do it without writing any code. You can present relevant IoT data and alerts and analytics, which can be understood in the context of the physical products and systems that they're relevant to. And what I think is most exciting is that the power to make that change, to fundamentally redefine the way that we communicate and present information, is in all of your hands. And it's fast, and it couldn't be easier.
Okay, so this is all about the sessions. Sorry for the delay of 15 minutes.
Not an issue, Praful. I'm very much thankful to you, Praful, for conducting such a grateful session for our students. I am very much confident that your session will definitely motivate our students to do projects in IoT. So thank you. Now, lastly, I hand over the session to Ms. Professor Priyanka for vote of thanks. So before that, if any student have a query, can ask. If you are any query, can ask. Anyone have a query? Yes, Jayan. Okay, so now I hand over the session to Professor Priyanka for vote of thanks.
Okay, thank you, sir. Good morning, everyone. So now moving to its vote of thanks, I would like to extend my gratitude to our resource person, Mr. Praful Bendarkar, sir, for guiding the students. Sir, whatever information shared by you, definitely our students will take the benefit of this. Also, I must thank to Head of Computer Science and Engineering Department, Dr. S.B. Patil, sir, and Head of IT Department, Professor A.S. Manikar, sir, for giving permission to organize this skill development program. Also, I would like to thanks to all the students for their active participation. So, thank you everyone once again for making this skill development program successful. So, here I declare that today's program is over. Thank you.
Thank you, everyone.
Thank you, Praful. Thanks to all the students.
Yeah.